we have Chuck Mills, who's the Director of Engineering at the Asphalt Pavement Association of Michigan. So Chuck joined the Asphalt Pavement Association of Michigan in 2005 as the Director of Engineering. Chuck works closely with the Michigan DOT, other public and private pavement owners, and the Asphalt Pavement Association members of Asphalt Pavement Association of Michigan members to provide high-quality asphalt pavements. Chuck received his Bachelor of Science in Civil Engineering from Michigan State University. He brings to the association many years of diversified engineering and construction experience. Prior to joining APAM, is that
APAM, yeah.
APAM, all right. Mr. Mills served jointly as Director of Technical Services for the Michigan Infrastructure Transportation Association. You guys have got some names.
Yeah, a lot of acronyms.
And the Michigan Pavement Association, all right.
Well, thanks for having me today. I'm here to talk a little bit about Thinlays. You know, it's a pavement preservation treatment. Thinlay asphalt pavements have become increasingly more popular over the last several years, especially as the infrastructure emphasis in the U.S. has switched from construction of new facilities to this preservation mentality. So we all want to keep our good pavements in good condition, so Thinlay is a way to do that. A lot of agencies have discovered many asphalt pavements do not require anything more to keep them in service than a thin overlay or a mill and fill to improve the smoothness and the safety of that surface. So Thinlay asphalt overlays have a number of advantages to recommend their usage. Most importantly, they provide long life and low life cycle cost. Their application provides a mean of maintaining grade and slope on a road. So anytime you're paving an asphalt, the floating screed of the paver allows you to fix up the cross section of a road and any dips in the road, so you can really maintain the grade and slope. They provide a quiet pavement surface. You know, you use standard paving equipment. It's simple to do. By the time you're done rolling the pavement, you can open it back up to traffic, so it's very quick as well. In Michigan, we call our Thinlay asphalt overlays HMA Ultra Thin. So I'm going to talk a lot about Ultra Thins today here. You know, Ultra Thin is the high value pavement enhancement. It was, you know, done to extend the life of your pavement, restores pavement smoothness, and protects your pavement structure. So I'm going to talk today about kind of the development of the specification, where we've been, and how it's performing over the last several years. So what is HMA Ultra Thin? It's just a dense graded asphalt mixture that's designed to be placed at 3/4 of an inch to an inch thick. So if you're familiar with asphalt mixtures, we're basically using smaller aggregates in this mix. So what is the purpose? Obviously, we want to protect the pavement structure, slow the rate of deterioration. You know, we want to preserve that pavement. That's what pavement preservation is all about. We want to take our good pavements, do a surface treatment to them, and prolong their life. Original performance targets, so I'll talk a little bit about how we kind of came up with the specification. You know, we're looking at low to moderate volume roads to start with. We're looking like an alternative to like chip seals. We really wanted the ability to improve ride quality. And we were looking for a life expectancy of, you know, extending that pavement's life about 6 to 8 years. We started looking at pavements that we had placed, you know, in the early 90s. We started down this process in the late 90s, you know, I think it was about 98, 99 when we were putting together the specification. So we did a survey of our membership because, you know, a lot of the asphalt pavers were making what we called sand mixes for local agencies and stuff. And they were basically doing these thin overlays for years. So we just wanted to kind of formalize it, especially for the DOT. They wanted to have a specification. So we gathered the information on these mixes that, you know, our contractors had been producing for years. And so we just kind of, that's where we started. So MDOT implementation, as I said, we wanted to kind of put together this specification for MDOT. It's an alternative to microsurfacing and chip seal, so it's in the pavement sealing category of the MDOT Capital Preventive Maintenance Program. The specification was developed by a group of industry people as well as the DOT. The mixture properties and materials are engineered for specific traffic levels. You can't really see this, but this is our current 2020 spec. We just came out with a new spec book in 2020. It finally came out this year. This is our 2020 version of our special provision for HMA ultra thin, and I'll go through a little bit of the details. I don't want to bore anybody. I won't spend too much time on all the specific details, but we do have the different traffic classifications. So we've got basically a low volume, a medium volume, and a high volume. And we break that down based on commercial ADTs. And so with the different volumes, it changes our design a little bit. You can see on this physical properties of the aggregates. Basically, as we get into the higher volume mixes, we've got more crushed, more tougher materials in that. Same methodology we use for designing all of our asphalt mixtures. Volumetrics, when we originally came up with the HMA ultra thin, it was a Marshall mix design, and back in 2012, MDOT got rid of all their Marshall mixes, so we converted it into a super pave mix design. So your air void, your VMA finds the binder. Along with the 3 different traffic classifications, we use 3 different binders. So for low volume, we're using a 58-28 binder, performance graded binder. And then our medium volume and high volume, we're using a polymer modified liquid asphalt in those. So the specification covers the materials, the construction and quality control, and it also includes a warranty. At MDOT, they use performance warranties for all their surface sealing and CPM fixes. It's a 2-year performance warranty, and for the ultra thins, it covers rutting, raveling, bleeding and flushing, as well as debonding. So current MDOT practice, the low volume and medium volume ultra thins are in their regular surface sealing category. So it competes there with the chip seals and the microsurfacing. It's still considered an emerging technology on high volumes. We just haven't done enough high volume roads with a long enough period of performance history to really say, yeah, well, let's put that into our regular category. I think we're getting close to that. I know that over the last few years, we've started to see more high volume applications, especially down in our Detroit area. So what kind of pavements are good candidates to place an HMA ultra thin? Like I said, any of our preventive maintenance treatments, we want to put them on pavements that are in good condition. But really, you want to have a good cross section, a good base that's structurally sound. I always tell everybody you can't expect a 3/4 inch overlay to go over something with a bad base that's moving around, because what's it going to do? It's going to crack. It's not really going to give you what you think you should be getting. So you can have visible surface distresses, moderate cracking, raveling, surface wear, slight to moderate flushing or polishing, an occasional patch in good condition. You know, I always tell people if you're looking at a stretch of road, a 2-mile stretch of road, and maybe you got one bad area where there's some base issues, but the rest of the road's in pretty good condition, well, instead of rehabilitating that whole road with a larger fix, you think ultra thin might be a good candidate there. Just patch up that little area and then ultra thin over everything else. So next, we'll get into talking about performance. You can't see these. These are just kind of. I've been with the asphalt industry since 2002. That was right about the time when the first ultra thin specs were coming out, and I've really kind of. Prior, you listed a lot of the things I've had varied experience to. I used to work with the DOT as well. I was a pavement performance engineer, and I worked as a region designer. So I've always had kind of a bent for looking at pavement performance, and I guess I'm kind of nerd with data. So, but The DOT actually does a great job in looking at their pavement performance and their tracking of data for all of their pavement segments. So we have what we call a distress index, and it's kind of a combination of, a measurement of how severe cracking is and things like that. So, but we've got all of this data, and I've really been tracking, ultra thins in particular, over the last 20 years. Just wanted to highlight, we're seeing very good performance with the ultra thins. And it seems to keep increasing. I started tracking this over 20 years ago, like I said, and the first time I started putting some of the performance data together, it was looking great, even better than we were thinking it would. And now every couple of years when I relook at it, it just keeps increasing. So it's really heading in the right direction. Wanted to highlight one project in particular. I call this my pet project. It was one of the first medium volume ultra thins that was done in Michigan. It was paved in 2004, US 127 up in Roscommon County. I was actually out there when the contractor was installing it, so it was just kind of a thing we were in the process then to try to get the medium volume ultra thins moved into the regular category, so I was really, helping, just watch these things and helping prepare the reports in order to move that into the regular category. So I kind of took this project under my wing. This project, when scoping the project, the original pavement structure showed some signs of oxidation, slight raveling, and a little bit of longitudinal cracking, but overall it was in really good condition. And they really wanted to, try this. And with the traffic levels, it fit into the medium volume category. So they wanted to try this. It was scheduled as an emerging technology program or a project. So within our CPM program, we have separate funding for emerging technologies so we can try out some of these new this is a construction photo here back from 2004. As I said, I've been kind of tracking it over the years. Here's some pictures. The one on the left, 2012, it's 8 years old. The one on the right, 2017, it's 13 years old. You see there's very little maintenance being done to this. Basically all they've had to do over the years is crack seal every once in a while, and really even that you don't see as many cracks. It's just been a very good performer. Here we are, last winter, 17 years old, still looking in great shape. Due to the great performance of this, it didn't just move into the regular category. It actually moved into the emerging technology into the regular category back in 2008. So we could tell from the first 4 years that this was a really good performer. Plus we had placed several other medium volume ultra thins around that same time frame, 2004, 2005. And so we put together a report. MDOT agreed to move that into the regular category. As I said, this was kind of, one of my pet projects, and the reason 2021 picture was the last one in there is because I was working with the National Asphalt Pavement Association on an article. And so this is from an article that we did on this particular project. It was published in Roads and Bridges last April. Just talking about, taking a proactive approach. So it talked about how MDOT is using their, capital preventive maintenance program to keep these good pavements in good condition. We highlighted, the good performing ultra thin pavements in here, and it was very well received. So that's enough on the 127 project. As I said, I've been tracking all of these projects for the last 20 years. This slide here really shows what we're seeing as far as performance on these projects. What are we getting for life extension? So I'm breaking this table down into low, medium, and high volume. You can see obviously we've got more of the low and medium. We've only done about 16 high volume ultra thin jobs over the years. But the average age overall is very good. What I do is I look at anything that's 5 years old and older, because our target range was 5 to 9 years. So I didn't want to really look at the 1 and 2 year olds, because it's 1 or 2 years old, it's just going to drag our average down. But Average age, end of service, the middle one there. Oh, I guess I got the little highlighter thing here. This one here. Average age, end of service here. So what that is 24 of those 46 projects have reached the end of their life. And that's the average age at which, they were. So 24 of those 46 low volume projects, average age when they were taken out of service was 9 years. So average age in service would be the balance of those 46, that are 5 years old or older. What's that average age? And then the average age overall is the average age of all of those. So we're seeing very good, average age overall, 10, 11, 8 years. When I first did this about 10 years ago, I think we were at more like 8, 7, and 6. So we're steadily seeing them continue to rise, which makes sense because as I'm going through, a lot of these projects, there's a lot more projects that are getting older and older, like the US 127 that's now 18 years old. We look at, these average life extensions, and like I said, I've been tracking all this stuff, so we look at every job that's let through the MDOT process. We got the cost per square yard. We weighted average that. And you can see, as you can see, the cost per square yard between, we commonly compare the double chip seals, our microsurface, and then our ultra thins are in our pavement sealing category. So, cost per square yard, we've been tracking, pretty close over all the years. I mean, I used to try to check this more often than I do now. Now I do it like once a year or once every other year because we haven't seen it bouncing around. So right now we're $3.50 to $4 a square yard for any of those fixes. So we calculate a cost per mile, 24 foot wide. We're typically just putting them in the driving lanes, depending on how the shoulders are. And then we take our life extension range, divide that, we get a cost per mile per year. So you can see the cost per mile per year is much lower when we compare the different fixes there. And the ultra thins are performing very well. So this chart here just kind of compares, what are the benefits between the different types. Ultra thin, chip seal, microsurfacing, they all do a good job. They're all thin applications. You can improve skid resistance, minimize curb loss, correct surface distresses. They're all good at that. Correcting minor rutting, you can do that with the ultra thin or the microsurfacing. The chip seal is not really going to help you with that. But where the ultra thin, differentiates itself is the ability to increase structural strength. With our MDOT roads, that's not as big of an issue because typically, most of especially our higher volume asphalt roads, you put 3/4 of an inch on a 12-inch thick pavement, you're not adding much structural strength. But, the county people who have roads that are, 2.5, 3 inches, 4 inches thick, if you're adding 3/4 of an inch, you're adding some structural strength to that road. So it can increase structural strength. Improving ride quality, as I said, you're paving through the screed, you're kind of smoothing out both your cross slope and your ride. So you really can smooth out the road, where with the other surface treatments, you're going to have the same ride as what you had before. So, so that's really what the point of this slide is, kind of differentiating what the benefits are. So really, again, the benefits, 5 to 9 year life extension. That was our original goal. What I'm seeing now after, tracking these things for 20 years, it's probably more than that. We are trying to work with MDOT. I know MDOT's had an intern a couple of years ago that started working on looking at performance curves, because when we do the actual performance curves and stuff like that, it's probably a little more detailed than my rudimentary analysis of it, but we're going to work together and try to come up with that too. Seals pavement to delay further deterioration, improve ride quality, improve skid resistance, maintains existing gutter pan. You know, you can feather the material down by the gutter pan along drives, that type of stuff. Some people will mill a little bit along the edge if you want to match it real nice. A lot of city people that have used ultra thin in the cities, you know, they figure by the time they're repaving those roads with an ultra thin overlay, usually the asphalt may be a little lower than the curb, and you can just pave right up to it. So you'd rather be a little high at the curb, make sure you got that positive drainage anyway. So minimize or eliminate structure adjustments, reduce noise, improve drainage. Ease of construction, standard paving operation. As I said, it's just a finer graded mix that we're using. So all the contractors readily, easily available to be able to make these mixes. And minimal construction time. With that, any questions?
Hi, Chuck. Great. Two questions. One, with having such a thin layer, bond strength seems to be really important, and we've used the SPO 95 in Missouri. So how are you guys addressing the tack? Are they doing anything different with keeping the tack on the road in front of this? Or are you putting it through a spray paver? And then secondly, what's the treatment at the end of life for this? Are they milling this layer off, or are they leaving it in place? And what's coming after it? So
yeah.
The tack, and then what's next?
We typically are using a standard tack. You know, we're not usually milling, so it's a thin layer. You know, usually when we're milling, we're putting a thicker coating of tack on it. But that is something that we're looking at. We don't use the spray pavers all the time. We do have paver place surface seal that we use also that uses the spray paver. We're looking at doing some pilots with the paver placed and the ultra thin and different tacks, spray paver with the ultra thin and things like that to kind of look at that. You know, we haven't seen debonding or you know, lack of tack being a big issue over the years. There's been some spot issues and things like that, like you always have with things, but I hope that, I'm not familiar with the spec that you pointed, the SP95, or is that the spray paver, like the No, that was the mix. So. Oh, okay. So that's like a thin lift mix that you guys have in Missouri? Oh, okay, 9.5 millimeter. Yeah. Yeah, this is actually like a 4.75 millimeter, so it's even smaller than that one. But the second question was, what are they doing at the end of life? What are they doing at the end of life? And it really depends on the road, I mean, and the condition of the road. I mean, sometimes it's getting milled off, sometimes it's, you know, getting another surface treatment put right on it. It really depends on, you know, what was the condition of the road when we did the ultra thin overlay, because, you know, some of the roads are a little further gone. Maybe after 4 years we've milled them off or done something, you know, bigger. And then you have the 127 where you put it down and, you know, 8-9 years later they did a crack seal, and now, you know, another 8-9 years they've done another crack seal, and that's all they've done. So it just depends on really like anything, you know, what we're talking about here with preventive maintenance is keeping our good pavements in good condition. So if we're put them on in good condition, you know, hopefully we can extend the life again using another surface treatment type where we're not doing a major rehab. But sometimes, you know, due to budget constraints and that, what do? We put in a preventive maintenance treatment where we probably shouldn't. So maybe we are milling it off, or we're doing a more major rehab is the next fix. So it really depends on what we're putting it on. Yeah.
Yeah, I had another question for you. What are you doing for prep? If you're not milling, there must be crack sealant issues, or are you leaving it there? Are you taking it out?
Just clean off the pavement. The MDOT spec does say to do crack sealing, and we try to do that far enough in advance so that we minimize some of the pickup issues and things like that. It's something else we kind of want to look at too, as well, as far as, you know, do we always need to do that or not? Those types of things. But yeah, so it doesn't, yeah, because there have been some issues with it picking up, or, you know, sometimes creating a bump as you're rolling it, different things like that. But I think what we've found is, you know, if you do it far enough ahead, let that crack sealant oxidize a little bit, it's a little less susceptible Plus, we kind of went through a time where we've, different materials react differently to the heat. The nice thing about the thin asphalt overlays is there's not as much heat generated. We were seeing more problems with our 1.5 inch, 2-inch overlays, things like that was causing a lot more of that bubbling up and stuff.
One comment that I have, and not really question, but we did do a 3/4 inch thin overlay on a road, and it almost immediately began delaminating in locations. And what we determined was that we did like 1.5 inch mill on it, but some of the original overlay was maybe, 3/4 of an inch, 1/2 inch thicker. And so we think that's what happened, and that goes back to that.
A little bit left delaminated
Just a little bit
underneath
left,
it, yeah.
and it was not necessarily good tack coat underneath that original surface.
Yeah.
And so we had good tack coat under the new thin overlay, but not very good under what was left over.
The original, yeah.
So, it gets back into the question of good surface prep and understanding what you really have there.
Yeah, that's an important point, understanding what you have there. I mean, typically with our HMA Ultra Thins, we're not milling. It's a straight overlay. So we're cleaning the pavement, prepping, tacking, and it's a straight overlay. Some people have milled the entire pavement. MDOT does it once in a while when we have under clearance issue on the highway or something, we'll mill a little bit there to put that in, but some cities have milled the whole surface. What you got to make sure there is that when you're milling it, that you're not getting too big of ridges and things like that. So you want to make sure you get a nice smooth mill so that tackle hold and things like that. So that is something you need to think of, because we had that issue on, even some of our regular 1.5 inch mill and fills. If the existing top course was 1 3/4 inches or something, and we're leaving that little 1/4 inch skin there, that, it can become a problem.
So thank you, Chuck. Great
Thanks, John.
presentation.
Thanks.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.